Okay, so for these, let's just see how you're sitting. The first one here, 4.2 times 10 to the 9th to the third power. Where do we start? 4.2 to the third power. So 4.2 to the power of 3, 74.088 times 10 to the 27. It's going to be 9 times 3. We do the multiply with the powers. So, of course, this has to be adjusted to 7.4088. Does the power get bigger or smaller? Bigger, so plus 1 would be 28. Over here, the fifth root. So we have to take the fifth root of 2.48832, which is 1.2. You guys remember how to do that in your calculators? A lot of you have a fifth root button. You have to do 5. Then you have to do X root, or my calculator, I have to use math key. Put in the X root. And then 2.48832. Get 1.2. If you can't figure that out on your calculators, let me know and I'll show you again. For most of you, you put in the 5, then it's the second, and then whatever you use for your power key, so it's your caret key usually. And then the 2.48832. Then what happens to our power of 10? Divided by 5, so it's 10 to the 6. And the already proper form, right number of digits in front of the decimal point, so we don't have to move anything. On yours? Here, on yours you have above your power key here. Right there, so you're going to put in on yours, you'll do here 5, shift, and then this key here. Then type in the 2.4. It's above the X to the power of key.
Mine, I'm getting 1,200,000.
You're going to get the second key. So yours you're going to do, oh, you're putting in the 230, 10 to 30. You do it just without that. 1.2. 5, shift, 2.4. Do the power of 10. Something went wrong there. I typed something wrong. Everybody else get it to work? Yeah, we can pretty much do a whole semester on just how to use the calculator. Yeah. Okay. Well, time to start our new stuff. Well, what's that? Yeah. It's a new week. We've only got 5 weeks left. I got to jam as much as I can in here. You guys only get to see me, what, like 21 more times? Then you got to go into withdrawals. Don't worry, though. I'll be back in the spring.
I was going to say, we got to thank
Yeah.
We got stuff on. We're already learning to track machine stuff.
We'll catch up. Don't worry. So today we're going to start talking about things like this. We're still dealing with the variables and the terms, and all those same rules apply, but now we're throwing in the equal sign in there. Of course, this is an equation. And the key to this, and making it work, is this symbol right here, the equal sign. What does it mean? It's always a tough question to answer, isn't it? It's equals. Well, yeah, it means x is the same as 7. It means what's on one side of it has exactly the same value as what's on the other side. In fact, you can think of the equal sign in an equation as a balanced scale. What's on one side of the equal sign exactly balances what's on the other side. Now, all equations start out in this form as a variable equals a number, or a number equals a variable. And they are built from there. So one of the first things we're going to look at today is building equations from this form. we have a few options. We have 6 operations that we have done so far: addition, subtraction, multiplication, division, and of course powers and roots. And we can do any one of those operations to build on to this equation. We could add. Let's say we're going to add 4. So now this is x plus 4. But again, this is a balanced scale. If I add to one side, not the other, it's going to tip. So how do I keep it from tipping? I do the exact same thing to the other side. If I add 4 to one side, I add 4 to the other side. 7 plus 4 is 11. So we have now built a slightly more complex equation. Well, most of the time what we're interested in is not building equations, it is solving equations. And when you're given that command to solve and you're given an equation, what it's asking you to do is to take that equation apart and put it back into that form. Well, this equation was built by adding 4, so how would we take it apart? Subtract 4. If we subtract 4 here, it takes that piece off, leaves us with just x over there. But again, because of that balanced scale, if we take 4 off of one side, the scale's going to tip, unless the exact same thing to the other side. We take 4 off the other side. 11 minus 4 is 7. We have taken this equation apart and put it back in its original form as a variable equals a number. And that's all we're being asked to do when we're asked to solve an equation, is take it apart and get it back to this original form. Now this equation was simple because we built it. We knew how it was built because we did it. So it was easy to take it apart. The tough part is figuring out how an equation was built. For example, we might have this. Now to figure out how an equation is built, the first thing we do is we find the equal sign. And then we identify which side of the equal sign has the variable on it. And in this case, it's over here. Then we have to ask ourselves, what is keeping that variable from being alone or by itself on that side of the equation? Well, right now it's the 3. So then the final question is, what operation is used to build that 3 onto the variable? Well, the 3 was multiplied to the x. X has been multiplied by a 3. That's how this equation was built. X was multiplied by a 3. So to take it apart, we're going to divide by 3. Gets rid of that multiplying by 3. But again, if we divide one side, to keep that scale balanced, we have to divide the other side. What's 36 divided by 3? 12. X equals 12. If we're not sure of ourselves, we can always go back to the original equation and replace the variable with that value. Is 3 times 12 equal 36? It sure does. Most of the time, most days it does, yes. So here, again, find the equal sign. Oops. Identify where the variable is. It's on the right side this time. What number or numbers is keeping the variable from being by itself? The 7. What operation was used to build it onto this equation? Subtraction. Right, 7 was subtracted. So to get rid of it, we are going to add 7. So adding 7 gets rid of the subtracting 7, leaving us with y. Again, because it's an equation, we have to keep it balanced like the scale. Whatever we do to one side, we have to do exactly the same to the other. 2 plus 7 is 9. So 9 equals y, or y equals 9. Again, you could put 9 back in here. 9 minus 7 does equal 2, so you have the exact same value on both sides. Or you could have so again, here's our equal sign, here's the side with the variable on it. It's the 3 that's keeping our variable from being alone, and what operation is used to attach the 3? It's dividing the variable. So to get rid of it, we're going to multiply by 3. So again, multiplying both sides to keep it balanced. 5 times 3 is 15. And again, you can come back here. 15 divided by 3 is 5. Any questions? Cool. We could also have something like that. Here's our equal sign. There's the side with the variable on it. What was done to the variable to build this equation? It was squared. So to get rid of it, we're going to square root it. The square root undoes being squared. Now again, we have to do the same to both sides. So x equals, what's the square root of 25? Or negative 5. 5 or negative 5. There are actually two answers to this equation. Either one of those would make this equation true. Because negative 5 squared is also 25.
So if you're solving that, which is the correct thing?
Really, you have to have both. Now, if it's a story problem or a situation, well, then the situation will tell you whether you want the positive or negative. In most cases, you do want the positive answer. Because in real life, outside of my bank accounts, there are very few negatives. But for you guys in CNC,
There's probably no squaring in the bank account either.
no, not a whole lot of squaring in my bank accounts. You're right. In CNC, though, because your coordinates and stuff like that, negatives do come up as far as your locations and stuff like that. So how about here? Square root of x equals 4. The variable, this is square rooted to build this equation. So to get rid of it, we're going to square it. So x equals 16. Not so bad. Sorry, didn't mean to yawn in your ear. Well, let's move on to something like this. So now again, we find the equal sign and we identify where the variable is. But now there's more than one thing keeping the variable from being alone. So what's been done to our variable to build this equation? Well, 7 has been subtracted and it's been multiplied by 3. Order of operations tells us what order this was built in. What is done first? Do we multiply first or do we subtract first? We multiply first. So when this equation was built, x was multiplied by 7 first. And then, or multiplied by 7. Multiplied by what? 3. There we go. Some of you are looking like, where did they come from? It was multiplied by 3 first. The little hamster is stumbling this morning, sorry. X was multiplied by 3 first, and then the 7 was subtracted from it. Now, if you think about it, if you put something together, let's say you put together a model or a piece of furniture that you bought, you just finished up, you just put on that last piece, and you need to take it apart again. What's going to be the first piece you take off? The last piece you put on. So that's the same thing with the equation. When we go to take this apart, the first piece to come off is going to be the last piece put on. So the subtracting 7 was the last piece that was built onto this. We're going to take it off by adding 7. So it's gone. We have to add 7 to the other side to keep my equation balanced. So over here, the minus 7's gone. We just have 3x equals 17 plus 7 is 24. Then what? Divide by 3. X equals 8. And as always, if we're unsure of ourselves, we can come back to the original equation. Instead of 3x, we make that 3 times 8 minus 7. Well, 3 times 8 is 24. Minus 7 is 17. So you do get 17 on both sides. So let's say we get 2y plus 9 equals 17. What was done to our variable to build this equation? Well, was it the 2 first or the 9 first? 2. It was multiplied by 2, and then 9 was added to it. So when we go to take it apart, what's the first piece we're going to take off? We're going to subtract 9. So 17 minus 9 is 8, and over here what's left is the 2y. Then what? Divide by 2. 4 equals y. Try that one in your notes quick. So where do we start? First thing we have to do is add 1, get rid of the minus 1. So 7x equals 56, and then divide by 7. X equals 8. And again, you could double check. 7 times 8 is 56, minus 1 is 55. So we get the same value on both sides of the equation. So here's one for you. When this one was built, two things were done to the variable. There's a square root and then adding 3. Now, order of operations says you square root first, but in this case, what do we do the square root first? No, if x were a number, the first thing we would do is add the 3, because that square root is an enclosing symbol, and adding 3 is inside of it. So you would add 3 first, and then it was the square root. So if we go to solve this, we have to get rid of the square root first by squaring it. So we square it, that cancels the square root, giving us just x plus 3 here. 4 squared is 16. Then what do we have to do? Subtract 3. So x equals 13. What do you think? Better than a sharp stick in the eye? So tell me what to do here. Do I have to square root first, or do I have to add 7 first? Add 7. Yeah, we stop and we ask ourselves, when this was built, if x were a number, the first thing that would happen would be squaring that number, then subtracting 7. So we have to take it apart backwards. We're going to add 7. So x squared equals 36. And then square root, giving us x equals 6 or negative 6. Here, however, is slightly different. If y were a number, would the first thing I do to it be to square it? No, the first thing I would do to it would be add 3, because it's inside the parentheses. We have enclosing symbols here. So because of the enclosing symbols, the first thing we've done when this was built, what was done to y was adding 3, and then it was being squared, right? So when we take this apart, the first thing we have to do is square root that. So we square root this. So the square root of y plus 3 squared is just y plus 3. It gets rid of the squared symbol. Now on the other side, we're going to keep this simple. Square root of 64, we're just going to say 8. Technically, it should be 8 or negative 8, and we'd have 2 equations we'd have to solve. But I don't want to get into that right now. That's not part of our happy thoughts for the morning. So 8, we're going to deal with the positive. 8 equals y plus 3. Now we can subtract 3. So 5 equals y. Put 5 in here. 5 plus 3 is 8. 8 squared is 64. That makes it true. The other way you do negative 8 equals y plus 3, you'd subtract 3. Negative 11 is also a solution. Negative 11 plus 3 is negative 8. Negative 8 squared would also be 64. But like I said, for now, we're just worried about finding that one solution, the positive solution. But you can see, no matter how complex these get, you just got to figure out how it was built and go from there. We could have something like this. This one looks really ugly. Now again, when we square root, we're only going to take the positive answer, even though there will be 2 here. We have to ask yourself, when this was built, what was done to x? Well, according to the order of operations, your first thing that would happen to x would be multiplying by 2, wouldn't it? Then when we got that number, we would subtract the 7. Then we would square it, because of the parentheses. Then it would be times the 5, and then subtract the 8, right? Well, now we do the same thing. We take it all apart. Add 8. So what's left here is 5 times the 2x minus 7 squared. 37 plus 8 is 45. Then divide by 5. So the 2x minus 7 squared, 45 divided by 5 is 9. Then we can square root. 2x minus 7 equals positive or negative 3. We're just going to stick with the positive. And then, of course, add 7. 2x equals 10. And divide by 2. Now, I'm going to let you off the hook right away. I will never, ever, ever do something like this to you on a test or a quiz. Unless it's an extra credit question. But I mean, I would never do that as part of the actual. But that is a neat little question. I mean, you can really go to town on some of these. Okay. I'm thinking it's time for you guys to practice a few. In your books, and I'm giving you extra time here because there's a lot of problems here. On page 368, it is exercise. This is the big book, by the way, 14-5. Page 370, exercise 14-6. Page 373, exercise 14-7. Now, these first few sets are really simple, like just adding or subtracting or multiplying, so they'll go fast. And then on page 375 through 376, this is really a little bit more difficult. Exercise 14-8.